Thank you very much for inviting me to speak on big data in this conference. My name is Vonu Thakuriah. I'm from the University of Glasgow, and what I'd like to do today is to talk about how big data figures in the future of cities, particularly with regards to the urban economy. Cities in the 20th century, as has been already said by the university's leaders, as well as Professor Konvitz, are massive drivers and concentrations of innovation and economic growth. But they are at the same time facing extreme challenges. And these challenges are manifold, and they are mutually interdependent. There are significant human and social challenges, ranging from the fact that 54% of the world's population now live in urban areas, a threshold that was crossed just recently, but has been increasing over time, and all kinds of access and other issues that come along with having to serve massive concentrations of human populations in small areas and giving them access to jobs, to education, to public services, hospitals, and a variety of other factors that make life in cities, or can make life in cities of high quality or make it of extremely poor quality. Cities are also at the center of a variety of environmental and physical challenges. Something like 75% of the world's CO2 emissions actually arise from urban areas, a significant contributor to global climate change and extreme weather conditions, variety of factors that affect every day. You hear in the news about hurricanes affecting coastal cities as well as cities in interior of countries, and the vast evacuation and other factors that are the result of it, which leads to significant issues relating to city management, not to mention real-time operations of infrastructure to get people to safety. Aside from that, the world continues to have bad air quality, particulate matter 2.5 in many cities around the world, responsible for various kinds of lung disease and breathing problems continue to arise. We heard recently about the big fiasco with some automotive manufacturers about how there were issues with their testing, environmental control, and so on. So those are challenges as well. Then a result of all these different factors, as well as a driver in and of itself, are a wide variety of economic challenges. The fact that the global economy is actually quite unstable at this current time. We did recover, in a sense, from a long recession that led to many different very unfortunate circumstances, pushing people to poverty and so on. So that's one aspect of it. But another aspect of it that probably is not thought about very closely, and which I believe is a very important consideration in managing cities, is the fact that the world's, especially in the West, the world's infrastructure, roads, bridges, tunnels, utilities are actually reaching the end of their design life cycle in many stages, requiring billions of dollars worth of investment that we really don't have money for. And that can, in fact, lead to immense impact on trade and economic systems in cities. And so these are all issues to really consider, and all of these add significant complexities, not only to urban governance, but also day-to-day management of cities. So here are some questions I like to think about when I think about the big questions that are facing decision makers. How do we operate cities efficiently and effectively? How do we build transport systems or energy systems, water management systems, and so on that work well, that work effectively in a less cost-effective way? How should we evaluate the potential consequences of complex social policy change, such as welfare change or health policy change, employment and education policy change on urban areas? What makes the economy resilient and strong? Now, that's a billion-dollar question right there. How do you develop economically shock-proof cities? How do we make our cities not go into the kinds of recession that we saw in the last several years, where houses were totally on foreclosure, on sale, and there were people pushed to living, in fact, in many cities in the US, where I moved to the UK from, they were living in cars because they didn't have houses anymore, let alone jobs. So how do you, in fact, recover from what are the good stories out there in terms of recovering from man-made terrorism, let's say, or natural disasters? What sort of interventions do you need in order to inculcate strategies for healthy behavior? What sort of strategies are needed for lifelong learning, civic engagement, and community participation? And how do you generate hypotheses so that you don't repeat some of the same mistakes about historical evolution of social exclusion and spatial disparities in cities? So now all of us know that these are very tough urban problems. There are significant constraints to addressing these problems. Of course, first thing that comes to everybody's mind is resources. Well, we don't have an infinite amount of money. We have to prioritize in making allocations. But that itself is very difficult. Even if the small amounts of investments that you can make are actually very difficult to determine which pathways you should take forward in terms of urban policy, because urban problems are wicked problems. Many times when you solve one particular urban problem, it rears its head somewhere else. For example, environmental problems are a particular case of wicked problems. So there are significant issues of lack of sustained, timely, and agile strategies to change. But even if there were timely, sustained, and agile strategies to change, there's little incentive to change in many cases because the policy choices are predetermined. There are vested interests by industry, by politicians, and so on, and little meaningful involvement by advocacy groups and citizens. So it all seems very hard. And why? Because a part of the problem where I'm coming from is that, well, you really don't have access to the high quality information that is needed in order to operate, plan, or evaluate urban strategies. Urban information is fragmented, they're highly siloed, they exist in different departments and agencies and so on, so none of them speak to each other. And this lack of timely, granular information that's meaningful to give insights into the contextual peculiarities and local experience that people can relate with, so that it is seen as solving their problems, that is not there. It's a very systems level overview of the issue. And finally, the lack of understanding by decision makers of the value that can be derived from data-derived strategies. These are some of the issues due to which there is a lack of high-quality information. So setting the stage, these are some numbers I picked out there, but the idea is that recently there has been, and on an ongoing basis, an explosion of data. There's an explosion of data because of increasing uses of the internet. Again, what internet means is itself changing because of all kinds of embedded technologies and so on. So it's not just me staring into the computer anymore that I'm accessing the internet. I might be accessing the internet in a wide variety of different ways. And the idea that, again, things are becoming ubiquitous and pervasive, and they're really connected to a wide variety of different things. So this explosion of information, as well as information that is routinely collected by governments and businesses and so on, are providing, I believe, an opportunity for us to sort of revisit some of these big questions, or to do it in better ways using some of these agile practices. So what do we mean by big data? Well, big data is one of the fuzziest words around there. It's very hard to measure, or it means 10,000 different things to different people. But I like to think of it as a wide variety or wide spectrum of data that are typically generated through transactional, operational planning, or social activities, and not all of which were designed specifically for research. So they were not designed through surveys or through questionnaires and so on. They occur organically as a result of businesses or governments doing their everyday business, or as a result of human beings generating information. The reason why big data has caught the imagination, if you will, of a lot of people is the complexities that are associated with this. And the complexities are myriad. They're really very complex in the sense that they're not only about information management, how do you manage all this data, and how do you extract information out of it, but also it has implications on the methods that are needed in order to infer knowledge out of the data. But perhaps in more interesting ways, these emerging political economies surrounding the data and really the scientific paradigm, the emerging scientific paradigms, and the theoretical and epistemological questions that arise with the use of the data that are what makes big data exciting. When I think about big data, I think about big data in those contexts. Clearly, if you look on the left-hand side of the table, these are different sources of urban big data that we use. Some of the major sources of big data are infrastructure-based or moving objects, sensor systems data. The fact that in a city, in a modern city, or even in an ancient city, everyday objects are getting embedded with devices that can monitor and measure things. So things in our environment, in the transport system, building management, and so on. And this is leading to the idea of Internet of Things, where billions of everyday objects would be embedded with devices that would ubiquitously and passively monitor and sense things. And these things are all connected. Some go on so much further as to talk about machine-to-machine communications, where you totally remove the human beings from the loop, and you have different devices connecting and talking to each other. And clearly that has, that in some ways it has many benefits for society, and of course there are as well several risks to society when you go into this kind of ubiquitously connected systems in terms of what will eventually happen with the level of automation. Perhaps most exciting in this area of big data is what people really connected to in a sense, is this area of user-generated content. The idea that human beings have gone from being passive subjects of surveys and censuses and questionnaires to actively procreating or co-creating data on a day-to-day basis as a part of their day-to-day lives. And they do this in a variety of different ways. They do this by being members of participatory sensing systems, citizen science projects, very well, things that probably are most near and dear to many people's heart, not necessarily my own, is social media, Twitter data, Foursquare, you name it. There's all these different ways by participating in which human beings actively procreate socially generated data. Administrative data from government sources can be open data in the sense that government agencies are putting it out there. And these are data on transactions, taxes, revenue, all kinds of different things that government agencies collect data on, as well as highly confidential micro-level, personally identifiable data relating to people's welfare benefits, education records, and so on, that constitute a major source of big data in urban areas. As well as the private sector as well. Businesses collect, as you know very well, every time you swipe your credit card, there's data on you and so on, all kinds of digital exhaust that's been collected by private companies. Now, the interesting thing is I really like this area. This arts and humanities communities have significant cultural repositories of text, images, sound recordings, linguistic data, as well as artifacts and objects which can be digitized to give you information on cities. And in fact, this can be some of the best longitudinal data that you can have on cities about how cities, different patterns, pockets, and neighborhoods changed over time in terms of the way people were, who lived there, and so on. Very rich sources of data. And finally, various linked data sources, as well as the data that you get by linking many different myriad sources of data, as well as synthetic data sources. The fact that you cannot directly measure many things that are of interest in the urban areas, like congestion, traffic congestion is not something you directly measure with any sensor. You have to derive it from some sensors or other ways. So there is very much an issue of synthetic data or simulated data. Enough of that. That's all the details about the data. Let's move on to see some real applications. So when people talk about big data, they really talk about two different things. And it's this, again, this lends to a lot of confusion. There is reference to big data as data, types of data, their characteristics. That means big, huge data sets, rate of generation. They're unstructured. That means they're not numbers anymore. They're text, they're images, and so on. And then also people talk about big data as an approach. That is a data-derived analysis and decision making. The fact that there's data-driven decision making, and it is a process rather than an approach, as the data, as opposed to being the data itself. So I like to think about big data as this entire process that you see in that pyramid. At the bottom, you have the big data infrastructure, all the sensors and administrative data, all the stuff that's producing the information. But you need to do analytics of it to extract and find out or discover knowledge. Data is not knowledge. Data is not information. You need to do something to the data, massage it, analyze it in order to find out something that's useful to you. But you can't just stop at knowledge discovery itself, because that by itself is not really useful to governance and practitioners. How do you create value propositions out of it, and how do you derive actionable strategies out of it? So that's another important step when you go up the ladder, the pyramid. And then what do you do in order for governments and businesses to adopt and implement these strategies? Only after you do all of that can big data lead to impact or meaningful outcomes in society and cities. So that's very important, because most of the academic community associated with big data actually think about the bottom three layers. The top three layers are seen as in the domain of governance, advocacy, activism, public and private leadership, and so on. And the bottom part is this area, emerging area on urban informatics that I'm heavily involved in, which looks at how we can create knowledge out of the data. So what is urban informatics? It's really about analyzing, visualizing, simulating, and understanding a wide spectrum of urban big data for the following four purposes: dynamic resource management, i.e. the question of how do you use all this data to manage cities efficiently and effectively. Second is knowledge discovery. How do you use all this data to extract patterns about cities, and so that you can discover what's going on, you can understand better. Urban engagement and civic participation, and finally urban planning and policy analysis. Let me give you some examples of some of the things that we have worked on in this area. Dynamic resource management, an example that I've worked on in the past is on connected systems, weather responsive traffic management, and fusion of real-time and weather data. So historically, weather systems that measure transport and weather are vastly different. They belong to different communities entirely, but we can now connect them, and we can use them together in order to predict traffic conditions, what kind of traffic conditions will be under bad weather conditions. Now, given the fact that a lot of traffic fatalities occur during bad weather, and bad traffic fatalities are in fact the leading cause of death for people less than 30 years of age, is a massive issue. And this is not stopping with this kind of systems. Your car can now sense weather patterns and take autonomously actions on the basis of that. Now, over time, we have also done other work, like how do you use Twitter data in order to find out where there is some sort of a car crash or road crash or something like that. And this is an example. These are all examples out of my research group in Chicago. So, we can use Twitter data actually quite effectively in order to understand where there is some kind of a disruption in the road system. And we can actually, when we find a tweet coming in, we can actually detect with about 86% accuracy that it is relating to an incident on the road. So these are some very small examples of the way you can use these very unstructured sorts of data to actually measure and monitor what's going on in cities. Knowledge discovery and analyzing social and economic aspects of data. Here is an example which again shows the city of Chicago, and this is an example where we are trying to find out how people in different parts of the city are responding to the fact that the bus system has adopted a real-time arrival system. And we find that people adopt technologies differentially, and this is reflected by the fact that in Chicago, which is quite a segregated city, there are different parts of the area where there are more digitally savvy people who higher income areas, which are more likely to be using this kind of technology and using the bus system more frequently as a result, compared to other areas where this is really not the case. So we can sense a lot of what is happening in the city using this kind of different sensor data. And it's not only the Twitter type of data that's a sensor. Public transport systems are one of the major sensors regarding what is going on in cities. An example that we are working on at the moment is the whole idea of collecting by design many multiple streams of data sources so that we can understand in a more holistic way biases and issues arising with naturally occurring forms of data. Naturally occurring forms of data are not representative like well-designed social science survey data. For example, many social media users are young people, or they don't represent the total population. So how do we measure all these different sources of biases? So what we are doing in this example is we are collecting data that are, we're collecting data, a gold standard social science survey of about 1,500 households in Glasgow, and household members within those households. And they're given a questionnaire-based survey as well as a sensing survey that uses, where people are asked to use GPS devices and live logging devices with which they can go around and take still pictures and images of the city. At the same time, in the background, we are collecting data from various text-based and multimedia social data sources so that we can understand the context in which Twitter or Flickr or YouTube and all this data are occurring. Also, other data sources such as very high resolution data and LiDAR data, and the idea is to link all this together. So what this allows you to do is, on a continuous basis, it allows us to monitor different activity locations in cities. This picture you see on the upper left-hand side is actually data that gives you where people are most active within the city of Glasgow based out of GPS data. And that picture on the corner on the other side also gives you mobility patterns as discerned by this. And these are all events that we have detected using different social media streams. So the idea is when you collect data in this way, we are able to model and simulate life in cities so that we can understand the processes that are going on at any one time. Going more from the social side to the economic sort of side, this kind of data can potentially also have a wide amount of value in understanding fundamental employment, labor market, and economic conditions. Here is an example of where we have used a wide variety of different sources that are mentioned over there, and some of this is it's in development stage, about how you can use all these data sources together to measure access to jobs by workers. And when I say access to job, it means if suppose you're a person who lives in this area, you want to know how many jobs are around you and what the spatial competition is for those jobs so that you can understand the potential you have about getting a job within easy commuting distance. Now, this kind of measures were typically derived using decennial census data, so government agencies have to wait every 10 years for these numbers to be updated. But now we can update them quite frequently, get them annually or quarterly on the basis of these emerging sources of data. Here's another example. Data on housing market dynamics is to emerge typically from sense surveys that are felt very expensive. Here what we are doing is web scraping of real estate agent housing for sale or for rent data. And we are linking it with sales records so that we can get very accurate and very frequent measures of where houses are coming up for rent or for sale and how long these remained in the market before they were rented out or they were purchased by somebody else, and so that we can get an idea about the dynamics within the city about where property values are doing well and where they're not. And so on and so forth. So we have many examples about how we can use these data sources in order to detect very fundamental changes in urban land patterns and the physical and built environment using this wide variety of different data sources. What we are doing is, as a part of the university's data center that I'll talk about in the end, we are putting them online, and we also have this group by means of which we are creating city dashboards, ISO standard, urban quality of life indicators, and the idea is that you could access this data if you went to our website so that you can study UK cities, and this is being done all over the world at this point for outside persons to come and use data that are being used by university researchers, and these are being released by open source technology. Now, here's the fun part. I think the way people engage in cities have changed. Urban engagement patterns and civic participation and data entrepreneurship. These are some of the big important changes that have happened with the data economy. Here's an example of how we can try to get children involved in understanding what's going on in their neighborhood and how to play through video games about what they would like to see changed in the neighborhoods and so on in their communities. So sort of catch them young, so to imbibe. It's very important, I think, the pipeline has to begin early. So this is, how many of you know Minecraft? I don't know how many of you know Minecraft. A lot of people probably know Minecraft. Well, I don't really know much about it, really. These staff has developed this. But the idea is we've taken the entire GIS structure of UK and put them within this environment. So the children can manipulate in the game what they would like the neighborhood to look like. So that's an example. But to me, the most important and interesting thing that's going on is about open data initiatives. And really, there's the fact that, these open government strategies release open data to reflect accountable and transparent government, collaborative government, and innovative government. This is a very exciting idea. And the idea that government data should be accessible to everyone to use and also republishable without copyright and other restrictions. What this has led to is a lot of innovation and actual interest by common people in cities to try to use data as a part of from all these open data portals that are stepping up all across the world in order to understand and come up with solutions and ideas about how to fix different problems in their cities. And this group of people who are actively mining data to fix their cities are generally usually called civic hackers, and we have been studying them for quite a long time. And a lot of the civic hackers actually, on the basis of some of the survey, are really motivated not only to improve their programming or other kind of skills, but also to promote urban engagement and improve cities, and also to improve social inclusion by strengthening access to data. They're very passionate about programming, but they're equally passionate about taking the data and fixing the cities, whether it is by writing an app for people to report where there's a pothole or something more foundational than that. So there's virtually many large cities across in the world, they have hackathons and so on, where they get together groups of people who have some interest in data and programming, and they give them open data that's been released by the government, local government, and they're asked to generate ideas about how to solve specific problems. Certainly, we've seen a lot of these in Glasgow as well as in Chicago and elsewhere. But the fact of the matter is, actually, we did this study, and we tried to find out who are these people, who are using all this information. Well, traditional urban data users were city planning organizations, operational agencies like transport or environmental agencies and so on, research organizations, and universities, as well as consulting firms. But now, you have what I'm calling emerging urban digital intermediaries, and there are 4 major groups of them. First of all, there are these large general purpose ICT, information communication technology intermediaries, like smart cities companies. Then you have urban service providers of various kinds, such as location-based providers that are extensively using this kind of data and generating actually money value out of it. Then more on the civic and do good for the society, public good side, you have a wide variety of organizations that I have classified under urban, open, and civic data intermediaries, and these include open data organizations, civic hacking organizations, and so on. And then finally, there are all kinds of independent and open source developers who are actually using all this data to make discoveries on cities. So these are the new phase of entrepreneurship in the big data economy. All of them together are leading to this whole idea of going from a very technology-entranced notion of cities called smart cities to connected and future cities, where participation and inclusion is becoming central. So it is technology at the core, but participation and engagement of citizens and different groups of citizens that are becoming an increasingly important part of it. So big data challenges going towards the end, technological, methodological, yes, but equally importantly, there are really strong theoretical and epistemological challenges. You won't solve everything with big data. You may not solve much at all. But I think what you will solve are very important, like I think health, traffic, transport, managing information in a wide variety of urban sectors, managing them efficiently. I think you will change them. I think you will make a difference in urban people to think about their cities, and that's very important. So, sort of understanding the validity of the approaches and limits to knowledge from data-driven approaches and deriving visions of what future cities should look like, I think will play would be a key outcome of the big data economy. And then the other big challenge is the political economy of data. That data has value, and people can actually sell it for a price or use it as a part of a power structure so that they can then determine who has access and who doesn't. I think that's a very big and important issue, and it's going to change the way cities are going to look like in the future. And this regarding data access, privacy, responsible innovation, and as well as emergent ethics. And this leads us to think about new potential metrics for how we measure future cities, going not only from things like impacts and outcomes and cost effectiveness, but also issues such as social interestingness, exploration, urban discovery, inclusiveness, and augmented mindfulness to understand what is going on with yourself out of personal informatics data. So big data and the future of cities, there are 5 themes going forward. I think the 5 overall challenges, policy challenges. Building and maintaining this infrastructure is going to be challenging. The analytics of it is going to be very challenging. But understanding that new norms of digital literacy are required for people to understand the full scale of what is going on with the digital exhaust that they leave and digital exclusion, and to understand that to have consumer awareness and the rights and responsibilities that they have within this data economy. That's going to be very important from an education and learning point of view. Raising awareness among decision makers about the value of data-derived economy, that's important. Capacity building, of course, we will need new sets of skills. We will need new entrepreneurial modes in order to deal with this data economy. Lastly, I wanted to say very quickly about the Urban Big Data Center, of which I'm the director and principal investigator in University of Glasgow. We are a consortium of 7 universities, including one in the United States, my former university, and it's funded by UK Research Council's Economic and Social Research Council. It's a very large entity, close to 19.5 million US dollars. So it is, what we do is actually, we are not only a research center, we run a national data service. So if you are a researcher, you can come to us. You could be a private company, or you could be a researcher, and you could come to us, and you can go apply through our data service to use our knowledge and our data in order to solve your city's problems. And so what we are effectively doing is building links among cities, local governments, businesses, and universities through data. And it is highly interdisciplinary, and I look forward to hearing from you on this exciting endeavor that we are undertaking. And with that, I will close up. Thank you very much.